Hello everyone and welcome back to the BEILab channel. Today, we'll explore the world of data visualization with a focus on one of the most important plot types, scatter plots in the Matplotlib library. But before we begin, if you're new here, make sure to hit that subscribe button and give this video a thumbs up. Your support fuels our mission to deliver valuable content to you. Now, let's begin our tutorial. A scatter plot, also known as a scatter chart or scatter graph, is a powerful tool that uses points to represent data for two distinct numerical variables. The position of each dot on the horizontal and vertical axis corresponds to the values of a specific data point. These plots are not just visual aids, but windows into the relationships, patterns, or trends between variables. They can reveal correlations, clusters, or outliers within the dataset, providing valuable insights that can significantly impact your data analysis. Now, let's start our implementation in Jupyter Notebook. In the first cell, we import the NumPy library under the alias NP and the Matplotlib library's pyplot module under the alias PLT. This is a crucial step as it allows us to access their respective functions and methods for numerical computation and plotting, which we will be using extensively in our code. Next, these lines of code use NumPy's functionalities to create sample data for plotting, where array X is populated with 50 evenly spaced values ranging from 0 to 2p, while array Y contains the corresponding sign values of each element in X. Now, this line of code uses Matplotlib's scatterplot function to visually represent data points by specifying the x and y coordinates of the data. The PLT for the show function is used to display the created plot on the screen. In the next step, this line of code creates a new figure with customized dimensions of 4 inches in width and 3 inches in height and a resolution of 200 dots per inch DPI, which determines the quality of the output when saved as an image file. The next code block sets labels for the x-axis and y-axis as x-axis and y-axis, respectively, and assigns a title sign function to the plot. Now, we use font size and font weight to control the size of the font and boldness, respectively. The next line code sets the font family for text elements in Matplotlib plots to Times New Roman. Next, several parameters were set for the scatter plot, such as color, marker, scale, and label. Next, we use the plt.legend function to add legends to the scatter plot. In the next step, a grid is added to the plot to enhance the readability of data points with a specified grid line thickness. Now, this code sets limits for the x-axis from 0 to 2p and for the y-axis from -1 to 1. Next, this code specifies the positions of the tick marks along the x-axis at values 0 through 2p. This section generates 100 random values between 0 and 1 for both the x-axis and y-axis using NumPy. To add labels and title, we duplicate the code from the previous cell and paste it into the current cell. Similarly, we duplicate the code from the previous cell to add a grid for the plot. Now, we create arrays of 100 random sizes and colors uniformly distributed within specified ranges. Afterward, various parameters, such as color, marker, scale, and label, were adjusted in the scatter plot. Thank you for joining us on this journey through bar plot data visualization. Don't forget to hit the like button and subscribe for more exciting content. If you have questions, suggestions, or specific topics you'd like us to cover in future videos, drop them in the comments below. Also, you can find code examples on our GitHub page. Stay curious, stay engaged, and we'll see you in the next video.